World Geography, Basics of Geography, Climate and Vegetation. After viewing this video, there are several learning objectives that you should have accomplished. Number 1, describe how the tilt of the Earth determines the seasons. Number 2, identify the factors which determine climate. Number 3, compare and contrast the 3 types of precipitation. Number 4, identify weather extremes. Number 5, describe the factors that contribute to climate change. Number 6, identify the climate subregions. Number 7, interpret a climograph. Number 8, describe the different vegetation regions. Earth-Sun relationship. Seasons. Due to the Earth's revolution and tilt, different parts of the Earth receive the direct rays of the sun for more hours of the day at certain times during the year. The tilt in particular causes the changing seasons. The northern hemisphere tilts towards the sun in summer and away from the sun in winter. The opposite occurs in the southern hemisphere. Solstice. 2 latitude lines, the Tropic of Cancer and the Tropic of Capricorn. These mark the points farthest north and south that the sun's rays shine overhead at noon. The solstice, this is the day on which the sun shines directly overhead. The summer solstice in the northern hemisphere, this is the longest day of the year. Winter solstice is the shortest. Equinox. Twice a year, on the equinox, days and nights worldwide are equal in length. On these days, the sun is on the same plane as the equator. Equinoxes mark the beginning of spring and autumn. You might want to pause here and study this diagram, determine what time of year the equinoxes occur and the summer and winter solstice, determine how the tilt of the Earth determines the changing seasons. Time zones. Humans divide the Earth's surface into 24 time zones, one for each hour of the day. The prime meridian at 0 degrees longitude, this is Greenwich Mean Time, or GMT. Actually, though, the day begins at the international date line in the middle of the Pacific at 180 degrees longitude. To the east of this line, back towards the United States, the calendar date is 1 day earlier than to the west, towards China. Here's a diagram of the different time zones around the world. If you wish, you can pause the video and study it. Weather and climate. Weather versus climate. Weather is the existing local conditions, including humidity, winds, and precipitation. It's the conditions pretty much right now or for the upcoming week. Climate, this is the average weather conditions of a place over a much longer period of time. Climate is affected by things like latitude, elevation, wind patterns, ocean currents, and landforms. Let's study each of these one at a time. Latitude. Temperatures generally decrease as you move away from the equator towards the higher latitudes, towards the poles. Geographers divide the Earth into 3 general zones of latitude. You can see them on the map. First is the low or tropical. Second is middle or temperate. Third is high or polar. Elevation. Elevation is the distance above sea level, and this often determines the regional climate. As the elevation or altitude increases, the atmosphere becomes more thin and the air temperatures drop. Vertical climate zones are the different climates that you find at different altitudes in the same area. Convection. Wind distributes the sun's heat from one part of the world to another through a process called convection. This is the transfer of heat in the atmosphere by the upward motion of the air. As the sunlight heats the atmosphere, air expands, and this creates a zone of low pressure. Cooler, dense air in a nearby high pressure zone then rushes into this low pressure area, and it causes wind and often storms too. Coriolis effect. On a global scale, the hot air flows towards the poles and the cold air moves towards the equator. Winds actually blow in straight lines, but since the Earth is rotating, they are turned at an angle. This is the Coriolis effect. In the northern hemisphere, winds turn to the right. In the southern hemisphere, they turn to the left. Ocean currents. Winds blow over ocean currents, and they affect the climate of the land that the winds cross. Ocean currents affect both the temperature and the precipitation received on the land. Cold ocean currents off the shore chill the air, and this prevents moisture from forming. You can see on the map the different ocean currents. The blue arrows are the cold ocean currents. Red arrows indicate warmer ocean currents. Landforms. Landforms also affect climate, especially in mountainous areas. Moisture-laden winds cool as they move up the side of a mountain, and they eventually release their rain or snow. However, when the winds reach the other side of the mountain, they are much drier and warmer, and don't contain much precipitation at that point. There are 3 types of precipitation. These are very important: convectional, orographic, and frontal movement. The first, convectional precipitation, this occurs in hot, moist climates, like Miami, Florida, in a subtropical area, where the sun quickly heats the air, the heated air rises, clouds form, and rain falls generally in the afternoon. Orographic precipitation. This type of precipitation falls on the windward side of hills or mountains that block moist air, and they force this moist air upwards. The air cools, and rain or snow falls. The land on the other side of the mountain, on the leeward side, this is called the rain shadow. This land receives little precipitation from the descending dry air off the mountaintop. Third, there's the frontal movement. This occurs in North Texas, and it is the collision between 2 air masses of different temperatures or density. Precipitation occurs when the lighter, warm air is pushed upward by cooler, dense air that slides beneath it. If you like, you can pause on this slide and study more about the types of precipitation in more detail. This is an animation of orographic precipitation outside Los Angeles. It shows the windward side of the mountain. In the desert, you see the leeward side, or the rain shadow. Weather extremes. Hurricanes. A hurricane forms over the warm tropical ocean waters off the coast of Africa. When these storms are over the water, they pick up an enormous amount of moisture and heat energy. These types of storms are called cyclones in South Asia and typhoons in East Asia. Upper air currents that blow from the east steer these hurricanes from Africa towards the Gulf region, the Gulf of Mexico region, towards Central America, Mexico, Florida, and sometimes up the east coast of the United States. Once near the coast, the hurricanes may cause wind damage, of course, but also they create a storm surge of ocean water that rushes inland and floods out homes, and unfortunately, people suffer and lose their lives. Tornadoes. Unlike hurricanes, you can see coming. They form over a few days. A tornado is a really powerful column of spiraling air that comes from strong thunderstorms, and it forms quickly without warning. It's smaller than a hurricane, but more powerful, and it only lasts a few minutes, but it leaves behind really immense damage. 3 out of 4 tornadoes occur in the United States. Blizzards. A blizzard is a heavy snowstorm with winds more than 35 miles per hour and reduced visibility. On the eastern and southern shores of America's Great Lakes, these areas experience lake effect snow, which can create days of heavy snow. The moisture in the lakes is picked up into the atmosphere, forms snow, and the snow is dumped onto the land areas. Droughts. A drought's a long time without rain or with minimal rainfall. Floods. A flood occurs when water spreads over land that's not normally covered with water. If the banks of a river can no longer contain the floodwaters, the excess water flows into the surrounding floodplain. Sometimes this happens with the Trinity River floods. It goes over its levees or banks and flows into floodplains that are meant to contain the floodwaters. Environmental challenges. Ozone layer. Free oxygen combines with oxygen molecules to create ozone in the atmosphere. Ozone absorbs the sun's ultraviolet radiation, so it's beneficial to human beings. The use of chemicals called chlorofluorocarbons, or CFCs. These chemicals were used in coolants and refrigerators or air conditioners. They break down the ozone layer, since each CFC molecule damages the ozone molecule. Most countries have now banned CFCs. Pesticides. Pesticides are poisonous chemicals used to control insects that threaten crops. Unfortunately, pesticides can become part of the water and the soil and may be absorbed by crops that we grow for food. Acid rain. When coal and oil are burned, they dump pollutants into the atmosphere. These pollutants, like sulfur dioxide, turn into acids and are washed out of the air when it rains. These acids are toxic. They kill fish, they destroy forests, and they erode the soil. Climate change. El Niño. The warming of the waters periodically off the west coast of South America, this is called El Niño, and it's a natural change in the climate. About every 2 to 7 years, the easterly winds that blow over the central Pacific Ocean, they slow or they reverse direction. This changes the ocean temperature and ends up affecting worldwide weather. In El Niño years, westerly winds blowing towards the United States push warm water and heavy rains into the region. Greenhouse effect. Scientists hypothesized that recent global temperature increases are called the greenhouse effect. Gases released by the burning of coal and petroleum traps solar energy like a greenhouse does, and this causes high temperatures in the same way that, as I just mentioned, the greenhouse works. If global warming continues, polar ice caps and glaciers may melt, and this may flood coastal areas. Climate subregions. Tropical wet. The tropical wet climate subregion has very little variation in temperature over the year. It's always hot. Days begin sunny, and then often by afternoon clouds form and rain falls daily. This climate subregion is found in Central and South America, as well as Central Africa and in Southeast Asia. Tropical wet and dry. The tropical wet and dry climate subregion has a rainy season in the summer and a dry season in the winter. Temperatures are cooler in the dry season and warmer in the wet season. These type of climate subregions are found adjacent to the tropical wet climate subregion. Semi-arid. The semi-arid climate subregion does not receive much precipitation. Think West Texas, for example. Summers are hot, winters are mild to cold. Semi-arid climates are found in the interiors of continents, away from the ocean, or in a zone around deserts. With extensive irrigation, using the underground aquifers, underground water, this climate can produce good agricultural products. Desert. The desert climate subregion is defined by limited rainfall, not by how it looks. It's defined by its lack of precipitation. The desert climate receives less than 10 inches of rain per year, and deserts can be either hot or cold. The hot desert climate has low humidity and high temperatures during the day. At night, the temperatures drop dramatically because dry air does not hold heat. Cool or cold deserts are often found in the rain shadow of a nearby mountain range. Mediterranean. The Mediterranean climate subregion is named for the land around the Mediterranean Sea where it is located. This climate also exists along the western coast of the United States around Los Angeles and in parts of Australia. Summers are dry and hot, and winters are cool and rainy. The Mediterranean climate subregion supports a dense population, lots of people, and rich agricultural activity. Marine West Coast. The Marine West Coast climate subregion is located close to the ocean. In this area, the climate is frequently cloudy and foggy and damp. Winds blow over the warm ocean waters, and this moderates the temperature and keeps the climate relatively constant year-round. This climate is found around the west coast of the United States and Canada, not near Los Angeles, but further north from San Francisco up through Oregon, Washington State, and then up to Vancouver. And this climate is also found in most of Western Europe. Precipitation is evenly distributed throughout the year. Humid subtropical. Long periods of summer heat and humidity characterize the humid subtropical climate subregion. You might find this region in Houston, for instance. This climate's found on the eastern coast of continents, often subject to hurricanes in late summer and autumn. You find this in the southeastern part of the United States and in coastal China. Winters are mild to cool, depending on the latitude. The climate is suitable for raising crops, especially rice. Humid continental. The humid continental climate subregion is found in the mid-latitude interiors of northern hemisphere continents. Here in North Texas, we experience the humid continental climate subregion. Air masses chilled by Arctic ice and snow flow south over these areas, and they collide with the tropical air masses coming up in our area from the Gulf of Mexico. This causes rapidly changing weather conditions. These climates experience 4 seasons, and the length of each season is determined by latitude. Subarctic. Evergreen coniferous forests, known as taiga, cover the land of the subarctic climate subregion, especially in Canada and Russia. There are huge temperature variations between summer and winter. Summers, though, are short and cool, and winters are very cold. Tundra. The flat, treeless lands form a ring around the Arctic Ocean and are located also in the tundra climate subregion. This climate subregion is located almost exclusively in the northern hemisphere. There is little precipitation, less than 15 inches per year. There is permafrost, where the subsoil is constantly frozen, and summer lasts only a few weeks, and the temperature reaches only slightly above freezing. Ice cap. Snow, ice, and permanently freezing temperatures, these characterize the ice cap climate subregion. It's so cold here that it rarely snows. People call this the polar desert because there is less than 10 inches of precipitation per year. Highlands. The highlands climate subregion varies with latitude, elevation, topography, and continental location. Generally, any place you find high hills and mountains, this is the highland climate subregion. Interpreting climographs. A climograph is a useful tool. It displays average daily temperatures and precipitation for each month of the year for a specific location. In general, the lines on the graph allow you to identify average temperature, while the bars are used to identify average rainfall. If you know how to read a climograph, then you would want to look at one whenever you're traveling. If you're traveling to London in June, then you want to know what the average rainfall and temperature is so that you know how to pack. If you're going to Afghanistan, you need to consult a climograph. You need to know what the general weather is like. You might want to pause the video at this point and look at these two climographs for Bamako, Mali, and Kisangani, Democratic Republic of Congo, and come to an understanding of how the bars and lines make up the different elements of the climograph. Vegetation regions. Biomes. Soil, temperature, and moisture influence the type of vegetation that thrive in a region. Vegetation patterns are identified on the basis of the ecosystem they support. The ecosystem is the interdependent community of plants and animals. A large ecosystem, a regional one, is a biome, and biomes are divided into forest, grassland, tundra, and desert. Forest lands. Forest regions are characterized by the types of trees they support, either broadleaf or needleleaf. Broadleaf trees, trees like maple, oak, birch, cottonwood, we also call these deciduous trees. Rainforests, these are broadleaf trees. Most deciduous trees, not the ones in the rainforest, but most others, lose their leaves once a year. Needleleaf trees, trees like pine, fir, and cedar, these are also called coniferous trees because they are cone-bearing. There's some evergreen, picture of an evergreen forest. Here you have a rainforest. And these are deciduous trees in a broadleaf forest. Grasslands. Grasslands are mostly flat regions dotted with a few trees, and we describe them using different terms. In the tropics, particularly in Africa, we'll refer to a grassland as the savanna. In the northern hemisphere, a grassland can be called steppe, plain, prairie. These are all temperate grasslands. In the southern hemisphere, in South Africa, the name veld is used. In South America, the terms pampas and llano are used. Tundra and desert. In the tundra, plants hug the ground, plants like mosses and lichens. These types of plants are best adapted to survive this cold, dry climate. In the desert, plants can conserve water and withstand heat. Plants like cacti, sagebrush, or other shrubs, these are the types of plants that dot the landscape. Thank you for your time, and that's it.